Hello everyone. So I am here again with yet another video based on electromagnetic spectrum. So what we are going to discuss in this video is all related to what do you understand by this word electromagnetic spectrum. Now as you can see here rays of magnetic radiations are mentioned here. They are of different wavelength and different energy. So how have you got this kind of spectrum will be discussed in the video further. So let us see one by one. Before going to the detail of spectrum, I would like you to remind one thing, that we have EMR, which is electromagnetic radiation. And when this radiation falls on any kind of sample, let's say this is your sample and this is the radiation which is falling on that sample. Now what happens to this sample that we want to detect? So using any kind of detector, we'll be able to see what kind of influence this radiation is making on this sample. So this is what interaction of electromagnetic radiation with matter. We call that light as electromagnetic radiation because it is having both nature, particle and wave. So it flows like wave and it has particle nature where the energy can be quantized in terms of h nu. You can refer to my separate video which is totally based on electromagnetic radiation. So let's go further with the spectrum. Now what happens is when the electromagnetic radiation falls on the sample, there are certain transitions which takes place. Now if you can see here, this one is electronic energy level. I hope you remember that the matter has a ground state, matter has a excited state and all. And in between these transition levels, there are more levels like that of vibrational and rotational. So these levels which are in between, they are nothing but vibrational levels, and in between vibrational levels you have rotational levels. So here you can see rotational levels are there, these are vibrational levels, and overall you have electronic level. So first level is electronic energy level, and for an electron or anything to pass from one electron level to another electron level, this much energy is required, and that is what you are allowing it to pass. So if it absorbs that much energy, it passes from one state to another state. That is electronic energy transition, and this energy is actually very high. Now if you see the value, it is high. So the molecule has to absorb the radiation in that particular value, and then the electron is promoted from lower energy state to the higher energy state. Now if we go further with the levels, as I said that the electronic level is further divided into vibrational, which is further divided into rotational. And that directly means that the energy required for a molecule electron to transit or to possess this rotational transition means the molecule is here and then it is just possessing a rotational transition. So that particular transition is very easy to make. So it requires very less energy. While if you want that molecule to vibrate also, in that case, the vibration, if you see, the vibration is requiring more of the energy, and at the same time electronic energy is more. So that is what I want to say, that if you want to the electron to transit electronically, the energy requirement would be highest and then followed by vibrational and rotational. So vibrational energy are little less energy level than that of electronic energy. So you can see here the energy level is low and this comparatively high, and then it is comparatively high. So this is rotational level, then this is vibrational, and that is electronic level. And based on that energy, this kind of transitions takes place. So electromagnetic spectrum actually deals with this kind of energy with different wavelengths and different energies. So of different wavelength and different energy, radiation will allow the electron to possess different type of transitions. If the energy is less, which is this region, it will only have rotational transition. If it becomes high, it will pursue vibrational, and if it is more like in UVV visible, it will possess electronic. So you should know which kind of transition is taking place. So there are basically three transitions which take place as per the energy level of the spectrum. Now let us see what do we understand by electromagnetic spectrum. Now the electromagnetic spectrum, as you can see here, this is nothing but a wave. As I said that EMR, it can be considered as wave also. And now if the wave is passing like this, right? So this is the crest and this is the trough. Now the distance between two crests or distance between any two trough is known as wavelength of the particular radiation. Now here you can see that they are very near. That means the distance is very less. So the wavelength is less here, right? Wherein the distance between the two crests is quite high. So you can say that the wavelength is high. So directly I want to say that they are basically categorized on the basis of their wavelength. So going from this left to right, this wavelength is actually increasing. There is an increase in the wavelength, and you can see from this pattern of the wave. Secondly, at the same time, using that equation, which was E is equal to hc by lambda, we can say that when the wavelength increases, energy of a radiation decreases. So at the same time, we can say that these gamma rays are having highest of the energy, while the radio waves are having lowest of the energy. So at the same time, when they are having highest of the energy, they are having lowest of the wavelength. So with respect to two, that is wavelength and energy, we have designed, we have seen this kind of electromagnetic spectrum. Now going from right, if you have a radio wave in the extreme right, that means what they are having? They are having highest wavelength, right? And lowest energy. You need to remember this fact. Similarly, if you go to extreme left, you will see the gamma rays, which are having highest of the energy and lowest of the wavelength. Now, what do I want to say with respect to this energy is, because this is having highest of the energy, it can penetrate up to atomic nuclei. So here, if the energy is less, radio waves are generally used, in frequency modulation or amplitude modulation or radios and TV and all. They all are working on those signals. Now, if you increase our energy a little bit, that becomes the microwave region. The microwave region can affect the particular electron. Here it was only, in radio waves it was only spin of the nuclei, while in case of microwave it could go to the rotational level. So microwave spectroscopy can also be termed as rotational spectroscopy. The electron can possess this rotational transition, followed by infrared, because infrared is having higher energy than that of microwave. So here a little bit of vibrational and rotational, both of the transitions you can observe, and that is how the another name of infrared spectroscopy is vibrational rotational spectroscopy. Now going to another range is visible range. Now whatever color we see is because of this range only. So the wavelength of that much range is visible to our eyes. And now if you go to one more section, which is of comparatively higher energy, is ultraviolet rays. Infrared rays you can observe as a heat, and UV rays you also have observed. The sun rays are required for generation of vitamin D, but the highest amount, like if the amount goes high, it may cause a sun tanning. So that from here the energy becomes excess and your body is not susceptible to it. And then you can go to, like here you'll be having electronic transitions, and then if you go further, the energy increased further. So X-rays can penetrate towards your body, and you have seen X-rays, right? So they can go down to that level, nuclei level, and then this was all ultraviolet and visible and infrared. They all were, you can call them as a molecular spectroscopy, because they have that much energy which can transit or affect a molecule. But this is an atomic spectroscopy. X-rays can go down to atoms. And if you go further into atoms, if you are able to affect nuclei, that is possible with gamma rays. They are having highest energy. So if you go from left to right, you have to consider the fact that the wavelength is increasing. And if you go from right to left, you have to see that the energy is increasing. So it's very simple that based on that only it is classified like that. Now let us revise this fact in another manner. So I found this image also. So it's just to revise the thing that from extreme left you have gamma rays followed by X rays, which is next is UV, and then you have visible light, which further goes, you can explain it from 400 nm to around 800 nm. It is the range, and then it goes to infrared, where we can observe it as a heat, and this is giving you vibrational and rotational transitions, and this is giving you electronic transitions. Overall they are molecular spectroscopy. And going further, here you have atomic spectroscopy, and then in radio waves or microwaves, this is another region, so which I have already explained to you. Now I want to see this, so let us go in detail of this spectrum also, because we have discussed UV and X-rays and IR rays. So visible spectrum also, this is quite familiar to you. I know that you know this. We used to refer this as Vibgyor, like violet, indigo, and so on. So these are the colors and these are the ranges, and that is how we see color, that is how we are able to see this beautiful world. And UV always go side by side with visible in terms of spectroscopy, if I say. So around 400 till 400 it is UV range, and then visible range starts from here 400 to around 800 nm. So let us go further with this. Basically I want you to emphasize on type of energy. This much, as I said, this was having higher energy, right? So it was able to break the bond, it was able to hit the core level electrons, it was actually able to hit the atom in as such. And then UV visible are comparatively lesser in energy with that, but it is capable of transiting electrons from one electronic energy level to another electronic energy level, and followed by molecular vibrations, which is having lesser energy. So the energy becomes further less in IR, which is infrared spectroscopy. It's more related with vibrational. And in near and far IR, it also consider rotational as well, because obviously rotational is having lesser energy, followed by vibrational higher and electronic higher. So this electronic is obviously going to have transitions of vibrations and rotational included in it. So now if you see the spectroscopy images, like the graphs, if you get, with respect to intensity and wavelength, if you go in this region, you will get the peaks like that, like they are giving you the peaks because there is of the transition. But when you see this electronic transition, it is always a band. It will be like this because it contains all those vibrational and rotational transitions also. That is why it becomes a band, and that is how it is also known as electronic band transition or band spectroscopy. And then you further go down to lessen the energy, it is vibrational in infrared, and then followed by microwave, which can only transit in rotational level. Radio frequencies are also important in terms of spin of nuclear and electrons. So in terms of magnetic field, if we want to study the sample with the help of NMR spectroscopy or ESR spectroscopy, radio frequencies are of importance then. So up till now, I think we started with this diagram only, and now I am ending myself with this diagram only. I just want you to remember this sequence, because like gamma rays are emitted from nuclei of radioactive elements, so it is having highest of the energy. And X-rays are comparatively less harmful than gamma rays, but they are also harmful for us in high doses. UV is responsible for sun tanning. Visible is responsible for whatever we see. IR we normally observe as a heat, and radio waves are very less energy, but they are having higher wavelength, and they are used in magnetic studies like MRI, magnetic resonance imaging, or nuclear magnetic resonance spectroscopy. So that's all from my side. I hope you are able to understand the concept of electromagnetic spectrum. Thank you for watching. Keep liking and subscribing. Thank you.